Hi, this is Michiel Borkent, the author of Clj-kondo and Babashka and Psy and other projects that you might be sponsoring. So this video I'm making exclusively for the sponsors as a small extra perk. But if there's anything other that I can do for you as a sponsor to make you feel special, like which doesn't cost me a lot of extra time that takes away extra time from open source development, then I'd be happy to consider this. I don't know if I'm going to make videos on a recurring basis, but it just seemed a fun thing to explore, and who knows. A thank you to everyone who is sponsoring me, most notably at Goji, who is sponsoring Babashka for $1,000 a month, and Cognitect, which is sponsoring on GitHub, and NextJournal as well for generous amounts of money. Thanks a lot. This really helps to continue the projects, and maybe in the future I can even dedicate more of my week time to these projects and improve them even more on a steady basis. So what I wanted to talk about in this video is the new release of Clj-kondo, which came out yesterday, which has 2 new features and a lot of bug fixes. One of the new features is support for core.match syntax in Clj-kondo. So Clj-kondo is a static analyzer for Clojure, which means it doesn't execute any code. But the problem that comes with this is that it also doesn't recognize macros out of the box. Because it doesn't do any macro expansion, because this requires evaluation of your code. So a lot of the core macros are supported, if not all, but for libraries this is not always the case. And core.match is a library which has a syntax like this. So you say I want to match on some data structure, and then I have some bindings and some things that you don't care about. And so prior to the release of yesterday, Clj-kondo would report this as a unresolved symbol because it doesn't know where A is coming from. So that is fixed now. The issue is already 1.5 years old, but now it's finally there. And it was the most upvoted issue, so that's why I decided to finally fix it. So let's see if I can maybe show this. So what I usually do is I go to a Clojure buffer, and then I just start typing some code. Require Clojure core match as n, or refer match maybe, and now match 1, 2, 3, and I want to match this on ABC, and if this matches I want to return A. So what you see now is that B is not used and C is not used, so this gets reported as unused bindings. So if I would use A, B, and C, then these warnings will disappear. So you can see that Clj-kondo now understands the syntax. There were a few difficulties to support the full syntax, because core.match also has things like when odd, for example. So if A is odd, then we continue matching, and then I want the B, now I want to be, so there was some extra work, well, I don't care about the A here, so I make it an underscore. So there was some extra work needed to support this syntax, because you have to detect if this keyword is used, and then this is a predicate and not a binding. So if you do oddx, that is unresolved because there is no function oddx, but odd is just a closure var. So this syntax is also supported. And also one reason why I wanted to support this this library is that it's now also part of Babashka. So you can execute this code using Babashka. So if we go to temp, I'll make the screen a little bigger and I'll show you the contents. So if I execute this with Babashka now, it should work, but I made a mistake. Pattern row has different number. Okay, yeah. So there is not a, so you get a runtime error here because this is a factor of 3 and here it expects 2 things. So maybe we can add another binding. Now it should work. So you see it's the number 2 comes out now. So yeah, we could maybe improve Clj-kondo to support if you match unliteral, then you get already warning here, but that seems like a niche case because matching unliteral is maybe not something you do often. So usually it's maybe something like this where x is a dynamic value. So yeah, I could maybe show how this is implemented a little bit if you're interested in that. Clj-kondo source impl analyzer match. Yeah. So here is the code that was implemented to support this. And so whenever, so I can remove this now. So whenever Clj-kondo recognizes a call to analyze match, then this function is called, and this is the expression, which is a rewrite CLJ expression, which contains all the location information and about the entire. So it's not an S expression, but it's a more indirect representation. So whenever it encounters such an expression, we pull it into the pattern and the clauses, and we just analyze the pattern as, yeah, it's just a regular expression, a regular closure expression that we need to analyze, which is this thing here. So in this case, it's a local. We just analyze that and it should be no problem. And then we match or analyze the clauses, which is this thing, and there can be multiple of those. So these clauses is what is the interesting bit to support. So we just go over each clause. So you have a clause and a return value. So here, this is the clause and this is the return value. So we analyze the clause, which is done in this function, and it returns a couple of bindings that might be used in this clause. So here we have the binding B and underscore A and the underscore here. So in this expression, these bindings are all valid. So what we do here is we analyze this expression and that returns bindings. And then we analyze the return value using these bindings in place. And so if it's just a token, if the pattern is a token, which means it's a keyword or whatever, then we just we have a function here. So it could be a local, because locals are prioritized in core.match, so they don't introduce a new. So if I put x here, then it matches exactly on the value of the local x, and it's not a new binding. So we have to take that into account. And then list has special meaning in core.match, and also vector. And in the vector, we do special checks for these when and guard things to support the syntax that I showed here. So that's more or less what, the main new feature for Clj-kondo in the new release that came yesterday. There is one other main feature, and which is very cool because that is used by Clojure LSP. Let me try to demonstrate that. So in Clojure you can have keywords. So you can have normal keywords like foo, or namespace keywords like foobar, but you can also have auto-resolved keywords which use an alias from that you introduced using as or using the alias function. So you can write this, and what this actually expands in clojure.string/bar. So if I would write this or this, these two keywords are essentially the same thing, but if you use grep or whatever on the command line for Clojure string bar, you will not find this one. And this is what keyword analysis is for, and this is used by Clojure LSP. So if you type LSP find references, it will now come up with both these keywords because they are both the same keyword essentially. And you can maybe see how this could be useful for finding specs that are also using these names or auto-resolved keywords, and also searching for reframe events. So this is Clojure LSP uses Clj-kondo under the hood to get analysis data, and this analysis data, let's see, is done like this. So you say keywords true, and then you let's see, foo, maybe just foo. Let me pretty print this. So what you get here is if you call Clj-kondo with analysis keywords true, then it will spit out all the keywords with the name, and if it has a namespace, it will also include that foobar. So here you see it has namespace foo, and if you do nsfoo require Clojure string as str, and you do str, then you will also see that it has the ns Clojure string and the alias str. So you can see that this keyword was referred by its alias. So that's exactly what's being used here. I hope this was a nice little extra tidbit to get some extra insights in what went on in the latest Clj-kondo. We have additional bug fixes. Maybe it's not that important or interesting to discuss, and maybe this video is already long enough, so I'll keep it at that for now. Hope you enjoyed it, and see you maybe next time.